Hello, myself Dr. PJD Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss about what is instruction cycle and what are various steps in the instruction cycle and how the instruction can be executed. What is interrupt? How it is associated in the instruction cycle? What are various varieties of interrupts can be discussed. At the end of this video, the student can gain knowledge regarding what are the interrupt, what are various instruction formats, how the computer can identify each type of instruction, how the execution of instruction can be take place, and what is interrupt, how these what are the various types of interrupts, how these interrupt can be associated in the with the help of instruction cycle can be discussed. So the basic agenda of this video is the introduction, what is instruction format, what is instruction cycle, what is interrupt cycle, and what are the examples. So here a program can be reside in the computer memory unit and consists of sequence of instructions. So a program is a collection of instructions and these instructions can be executed one after the another. So while executing these instructions by the processor, it can use a cycle for each instruction for execution. Each instruction consists of two parts, opcode and address. The instruction format generally consists of two parts. One is the opcode, the second one is the address field. The opcode specifies what is the micro operation can be performed, and the address specifies on which data these operations can be implemented. So the instruction format consists of the opcode part and the operand or the address part, and the MSB bit of this instruction register can specify the addressing mode. Here we are having two types of addressing modes. One is a direct addressing mode, the second one is indirect addressing mode. The direct and indirect addressing mode can be specified with a letter I. If the I value is 0, it is considered as direct addressing mode. That means what is the operand? The operand can be readily available in the memory at the specified address that can be in the instruction and the opcode operation can be applied on this address. And in case of I value is equal to 1, it is a indirect address. So during indirect address, the effective address of the operand can be specified in the address part of the instruction, so that two cycles are required in order to fetch the operand in case of indirect address. So here this is the addressing mode. So here the instruction format consists of opcode and address. Address can be 0 to 11, total 12 bits the address, and the opcode is 12 to 14, so it is of 3 bits. The 15th bit is specifying the I value. I value is 0 or 1. If it all I value is 0, it is a direct address. So here the I value is 0, it is a direct address. What is the address specified in the instruction? 457. There itself the operand is available and can be used in the computational part or the micro operational. Add micro operation can be implemented in conjunction with the accumulator value. In case of I is equal to 1, it is a indirect address. So in case of indirect address, the effective address can be specified in the address part. So here the address specified here is the 300. At the 300 location, where actually the operand is available, that address is specified. So 1350, at that location the operand is available. So this value in conjunction with accumulator value, the micro operation add can be executed. So in this way, the last bit is used to specify the address mode. What are the basic instruction format? How the computer can identify which type of instruction it is. With the help of this instruction format, the computer can identify three types of instructions. One is memory reference instruction. Second one is register reference instruction. Third one is input-output instruction. So in case of memory reference instruction, the opcode field can be 000 to 110. Then this value is present in the opcode, then it is a memory reference instruction. In case of register reference instruction, the opcode value can be 111, but the I value can be 0 in case of register reference instruction. So for both register reference instruction and the input output instruction, the opcode value is 111. Based on the I value, the differentiation between the register reference and input output instruction can be take place. So here if I value is 0, it comes under the category of register reference instruction. If I value is equal to 1, it comes under the category of input output instruction. So depending upon these opcode values, the type or category of the instruction can be identified. So here for instruction execution, some registers are required. So registers are the type of computer memory used to quickly accept, store and transfer data instructions that are being used immediately by the CPU. So it is a small storage that can be available on the CPU so that quickly the processing can be done with the CPU. A processor register may hold an instruction, a storage address or any data. The computer need processor registers for manipulating data and a register for holding the memory address. Various categories of registers are available. They are the data register. The data register holds the data that can be used for the processing, and it can be generally associated with the address register. So to perform the memory operations, these two registers can be associatively worked, and the address register is used to point the location in the memory. The data register is used to contain the data that is fetched or written to the memory. Next, the program counter register can be used to hold the address of the next instruction being executed by the CPU. Next, accumulator is used for processing, and accumulator register is generally holds the one operand of the arithmetic operations. And instruction register holds the address of the current instruction being executed. Next, temporary register, input register and output registers are used for to facilitate input and output operations, and TR register is used to store the temporary data during the processing. So these are the various categories of registers. So the address of current instruction being executed is stored in the IR register, and address of the next instruction that is being executed is stored in the program counter register. What is instruction cycle? An instruction cycle is typically a sequence of instructions which are arranged in a loop given to a simulation software or processing hardware unit. The instructions are stored in the memory unit of processor or CPU. Each time the processor unit follows the path, so the instruction cycle generally consists of 4 steps. Fetch the instruction, decode the instruction, read from memory addresses or get the operand, next execute the instruction. So these are the 4 steps. Those can be executed during the instruction. So the 4 steps are executed in a cyclic or in a loop fashion. So the first step is the fetch the instruction. What instruction can be executed that can be fetched and can be stored in the instruction register. Decode the instruction. You have to interpret the instruction and identify what category of instruction it is with the decode instruction. Read the address from the memory. So what micro operations, to perform micro operations, the operands can be fetched. So the effective address of the operand can be identified in the third phase. So the operation is mentioned and the operands are readily available. The first step is execute the instruction. So the first step is the fetch instruction. In this step, the given instruction is fetched or called from the stored memory address in the memory unit of the processor. In the decode instruction, decoding the fetched instruction from the memory unit of the processor. Read from the memory address. The decode instruction is read from stored memory address where the values or arguments are to be stored. Execute the instruction. The decoded instruction is executed in the steps. The cycle then continue with the first step. So these are the steps of the instruction cycle. So consider an execution of the add micro operation. So here get the first number from the given address. For example, that address is A. Get the second number from the given address. For example, B. Decode instruction using instruction decoder and perform the or execute the A plus B operation and store the result. So here the steps 1 and 2 are part of the fetch cycle. 3 is the decode phase. 4 is the execution phase. 5 is the write phase. So during execution only the result can be stored. So 4 and 5 comes under the execution step. What are the operations that can be performed during the fetch cycle? The fetched instruction is loaded into a register in the processor known as instruction register. The instruction register holds the address of the current instruction that is being executed by the processor. So here during fetch cycle, the program can be loaded in the memory. What instruction to be executed, that instruction can be fetched and stored in the instruction register. This is the first step. Next, the processor interprets the instruction and performs the required action. So generally, the actions are 4 categories. One is processor to memory. Data may be transferred from processor to memory or from memory to processor. The second action is processor to I/O. So during execution of the program, input-output operation can be required. So data may be transferred to or from a peripheral device by transferring between the processor and an I/O module. The third action is data processing. The processor may perform some arithmetic and logical operations on the data. So data manipulation micro operations can be performed. Next is control. An instruction may specify that sequence of execution can be altered with the help of jump instructions or call or branching instructions. So this is the fetch cycle or the fetch step. So how these fetch cycle operations can be represented in the register transfer language. So here the program is stored in the computer memory. Each instruction can be fetched and is stored in the instruction register. And the next instruction being executed is specified, the address can be specified with the help of PC. So PC address is moved to the memory address register. So next, because of MAR is clogged, so PC is unaltered. Now read the memory to the MBR. Memory buffer register or data register can hold the data. The next step is to copy the instruction from MBR to instruction register. So IR can hold the current instruction address, PC can hold the next instruction address with this RTL. Next, the PC value can be incremented. So these are the instruction fetch registers transfer language notation. So here, with these register language notations, the IR can hold the address of the current instruction being executed. PC is hold the address of the next instruction that is being executed by the CPU. Now, what is the execution step? So, processor, memory, data. So, here the data transfer for implementation takes place in two methods. One is processor to memory. The data sent from the processor to memory or from memory to processor. The second action is processor to input output from peripheral device to the memory or the processor or IO devices to the processor. So in execution cycle, processor implements important operations on the information. So here it has to control calls for the modification in the sequence of the data implementation. There are two methods associated for complete the execution cycle. Now we have to look into what is the instruction cycle. So here the sequence counter can be used uh, to first initiated to 0, and the address register during fetch phase, the PC value can be moved to the address register. So here from the memory address register pointed, those instruction can be retrieved and stored in the IR value, and PC value can be incremented so that it has to move and point to the next instruction. So here IR can point the current instruction, address of the current instruction. PC is pointing to the address of the next instruction being executed. So these two are the fetch phase or the fetch cycle. The second step is decode the instruction. So during decode, the instruction format can be used to represent. So here in the instruction registers, the 0 to 11 bits are used to specify the address register. So during the instruction format, so here 0 to 11 bits are used to specify the address, and 12 to 14 bits are used to specify opcode, and 15th bit is used to represent the I value. So here the decode operation can be used to specify the instruction format. So here the 0 to 11 bits of the IR can be used to store in the address register, and the 15th bit of IR is denoted with the I value, and IR 12 to 14 bits can be used for the decode or opcode operation. So these decoded value can be compared here whether it is 0 or 1. So if it all 0, it is a memory referenced instruction, and if it all 1, it is a register referenced or IO instruction. So if the opcode is 000 to 110, then it is a memory referenced instruction. So depending upon the I value, whether it is a direct address instruction or indirect address instruction can be decided. So if I value is 0, it is a direct address instruction. So directly the operand is available, execute the instruction. If I value is equal to 1, effective address is mentioned in the instruction format. So the operand can be fetched with the effective address and execute the instruction. So in case of memory referenced instruction, so here after specifying memory instruction execution, the I value can be compared in order to decide whether it is a direct addressing instruction or indirect addressing instruction. So if direct addressing instruction, operand value is directly available, so execute the instruction. The third step can be done. So here this is the second step, the decode step. The decode operation, after decoding the instruction in the instruction format, it is easy to identify the which category of instruction it can be. And here, after identifying it is a memory referenced instruction, we have to check whether it is a direct address or indirect address. So this is the third step, getting the effective address from the memory. And this is the fourth step for the executing the instruction. So in case of register reference instruction or IO reference instruction, the opcode can be 111. Okay, for both the opcode can be 111. So how can you differentiate whether it is a register reference or IO reference instruction means based on the I value. If I value is 0, it is a register reference instruction. So the operand is available in the processor register. So execute the instruction. If I value is equal to 1, it is a input output instruction. Get the data from the peripheral devices and execute the instruction. In this way, the instruction can be executed by following the first step: fetch, decode, get the effective address and the execute. Now, what is the state diagram for the instruction cycle? So, here fetch the instruction. So, the instruction address calculation can be done first, and with these address fetch operation can be performed, and instruction operating decoding can be done, and we have to fetch the operand. So, operand address calculation can be performed. With these address, the operand can be fetched. If it are multiple operand, more than one operand can be fetched. So data operation can be performed. Operand address calculated and store the operand value. After execution completed, storing result is completed. Again going to the next instruction. So in this way, the state diagram is used to represent the instruction cycle. So these are the various states. What are the states of the instruction cycle? The first state is instruction address calculation, instruction fetch, instruction operand decoding, operand address calculation, operand fetch, store the operand. So these are the states of the instruction cycle. So instruction address calculation, the address of the next instruction is computed and it is stored in the PC, program counter register. A permanent number is inserted to the address of the earlier instruction. Next state of the instruction cycle is instruction fetch. The instruction is read from specific memory location to the processor. So this instruction can be stored in the IARE instruction register. Next state is instruction operation decoding. The instruction is interpreted and the type of operation to be implemented and the operands to be used are decided. So decoding of a instruction can be performed. With this decoding, the category of instruction can be identified. Next, operand address calculation. So operands can be fetched from the memory. The address of operand is evaluated if it has a reference to an operand in the memory or applicable through the input-output. Whether the operand are readily available in the memory or they have to taken from the register or from the peripheral devices. Next state is operand fetch. So here the operand is read from the memory or the IO for data operation. So the data operation consists of actual processing of the instruction or execution of the instruction. After execution, whatever results are found, that can be stored respective register or from the memory, or they can be transferred to the IO in the store operands. These are the various states of the instruction cycle. Now, what is an interrupt? An interrupt is a signal that requests the processor to suspend its current execution and service the occurred interrupt. So, when a program, for example, this is the program, this program can be executed generally in a sequence one after another instruction. If at all an interrupt occurred here, the processor can stop the program execution, temporarily suspend the program execution, can return to the ISR, interrupt service routine, and move to this interrupt service routine and start executing it. After completion of it, it has to return back to the previous main program and can resume the execution of it. To service the interrupt, the processor executes the corresponding interrupt service routine. After the execution of the interrupt service routine, the processor resumes the execution of the suspended program. So here is the user program. This user program consists of instruction 1, instruction 2, instruction 3. Like this, the instructions are placed. So if at all an interrupt occur, then it has to move to the interrupt handler through the interrupt service routine. And the interrupt service routine can be executed whenever it encounters the return value. It has to move to the next instruction of the user program and resume its execution. So how it can be done means the return address PC value can be moved to the stack, and whenever a return statement is encountered during the execution of interrupt service routine, then it can be the PC address can be popped from the stack, and by using this address, the return to the user program to the correct location can be possible and resume the execution of the user program from there itself. So this is the interrupt, how this can be, the interrupt service routine can be executed. So previously, with an example, how the instruction cycle can be performed, we discussed. We taken one micro operation, that is the add operation, and what are the steps for executing this, and the steps 1 and 2 are part of his cycle, and 3 is decode, 4 and 5 are for execution. So in order to perform the add micro operation, get the first number from the given address A and get the second number from the given address B, decode the instruction using the instruction decoder, and perform the actual manipulation or the processing A plus B and store the resultant value. So here these steps 1 and 2 are part of the first cycle, 3 is the decode cycle, 4 and 5 are the execution. Now there is an interrupt at the end of the step 2. So here itself, if at all an interrupt can be occurred, then the value on the register is moved to the stack pointer. Then the new value address is given to by the interrupt is taken into the register, and interrupt instruction cycle can be executed. The ISR can be executed. Once this is over, or whenever a return is identified, the address can be popped from the stack and it can resume from the step 3 onwards from the user program. So in this way, the interrupts can be serviced. What are various types of interrupts? So interrupts are majorly categorized into 2 types: hardware interrupts, software interrupts. Hardware interrupts are maskable interrupts, non-maskable interrupts. So hardware interrupts can be generated with the help of the physical devices of the computer. If a processor receives the interrupt request from an external I/O device, it is termed as a hardware interrupt. So, peripheral devices can acquire the service with the help of hardware interrupts. Hardware interrupts are further divided into maskable and non-maskable interrupts. So, maskable interrupt is the hardware interrupt that can be ignored or delayed for some time if the processor is executing a program with higher priority are termed as maskable interrupts. So, lower priority interrupts can be delayed and higher priority interrupts can be executed. In a non-maskable interrupt, the hardware interrupts that can be neither be ignored nor delayed must immediately be serviced by the processor are termed as non-maskable interrupts. So, delay for the interrupt service routine execution cannot be considered for the non-maskable interrupts. Software interrupts means the software interrupts are the interrupt that occur when a condition is met or a system call occurs. So, through system calls, the software interrupts can be generated or they can be generated with the help of exceptions also. So, by using the program code, the software interrupts can be generated. So, how this interrupt cycle can be executed with the help of instruction cycle. So, here start the instruction cycle phases are the majorly considered two phases: fetch next instruction, execute the instruction. Until this is the instruction execution cycle. After executing the current instruction, the computer can check whether interrupt is enabled. IEN with the interrupt enable, IEN is interrupt is enabled or not can be checked. If at all any interrupt is present, then service the interrupt. So here interrupt cycle, the ISR has to be serviced with the same sequence. If at all no interrupt is disabled, then halt the program. So like this, at the end of each instruction execution, the check for interrupt can be done, and if at all interrupt is present, then the interrupt service routine can be executed by moving the PC address to the start pointer. After giving service to the interrupt, at the end whenever return statement is found, the PC address is popped from the stack and resumes the main program. So in this way, the instruction cycle with interrupts can be used. So what is the interrupt cycle? So here by using the R flip-flop, it can be identified whether the occurrence of the interrupt. If at all R value is equal to 1, interrupt cycle can be executed. If R value is 0, then instruction cycle is executed. So here the return address is location. PC value can be moved to the memory 0 address and branch to location, and the interrupt service can be executed, and the IEN interrupt enable can be make it as 0 and R value is 0 after providing the service to the interrupt. If R value is equal to 0, then instruction cycle can get executed. During this period also, with the help of peripheral devices, the interrupts can be raised. So, if interrupt is raised, that can be identified with the IEN. So, during instruction cycle, fetch and decode the instruction. During fetching instruction, if at all IO instruction, IEN is 0 or 1 can be checked. If IEN 0, it is not for the IO instruction. The operands are available either in register or in memory. Get the operand and execute the instruction. If at all IO instructions, then check whether it is for input peripheral or output peripheral with the help of FGI. If FGI is equal to 1 means it is input, take the input, get the input to the get the input or the data for execution. If at all FGO is equal to 1, it is an output device. So the output device value has to be taken and data can be displayed to the user. So during that time, the R value can be make it as 1. Why? Because here the input interrupt or the output interrupt is raised, then the R value can be make it as 1 to indicate that an interrupt can be occurred and can be serviced. In this way, the interrupt can be identified. So the R value is equal to 1, R flip-flop value is 1, then the interrupt can be identified. Not only that, during instruction execution also, with the peripheral devices, the interrupt can be raised. It can be identified with the IEN, interrupt enable value. If it all contains the 1, we have to identify the category of input, whether it is input interrupt or the output interrupt, with the help of FGI and FGO. In these cases, the R value can be again 1 in order to indicate that the interrupt can be raised. So this is the flowchart for interrupt cycle. What is the state diagram of the interrupt cycle? So here address calculation can be done and the fetch the instruction operation decoding, operand address calculation, multiple operands can be fetched, data preparation, operand address calculation, operand stored, and here check for the interrupt can be done. If it all the interrupt is there, that interrupt can be served and can be resumed the main program execution. So this is the state diagram of the interrupt cycle in association with the instruction cycle. So in case of multiple interrupts, there are two approaches to deal with the multiple interrupts. The first approach is to disable interrupt while an interrupt is being processed. When an ISR is executing, then if at all an interrupt is raised, that can be disabled. A disabled interrupt simply means that processor can and will ignore the interrupt request signal. So these are the maskable interrupts. The second approach is to define priorities for the interrupt and allow an interrupt for higher. So we have to rank the interrupts. The higher priority interrupts can be serviced first. Priority can cause a lower priority interrupt handler to be itself interrupted. So these are the two possible approaches to handle the multiple interrupts. One is you have to delay the interrupt while one interrupt is handling, and the second method is defining the priority for the interrupt, and accordingly the interrupt can be serviced. So in this video, have discussed about what is instruction cycle, how it can identify the type of the instructions by using the instruction format, what are the steps of the instruction cycle. If it all interrupt occurs, how it can be identified and how it can be serviced. What are the state diagram of instruction cycle and the interrupt cycle? What are the various types of the interrupts and how the multiple interrupts can be handled? Thank you.
Like, share and subscribe. Hit the bell icon for more updates.